Hello, 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 hello. Good evening, all of you. Good evening. Good evening, Ray. It's too much problematic, because the issue is that the technical team is on leave because of the New Year. So that is the reason why everything is getting complicated. So now, skip and end. All right. So let us see. Okay. Let's continue. Okay. Let's continue. Okay. So for the students who are joining new in this live, let me tell you that there was a 50 minutes live before the same live. Okay. The chapter name is also same. So you live choose in mundu, you go and first watch that live and come to this live. Okay. Good. So let's continue now. So we talked about work done by different forces. Kada? Good. Hi. Even if it's buffering now, you understand that there is this network problem. Okay, it will be resolved. Okay? Great. So question number 1 is I have to talk about, hey, you listen, I have different types of forces. Force number one that I have is, చూసుకోండి అందరికి. So the number 1 force that I have is your normal force. అంతే కదా? Yes. దాని తర్వాత it is your tension force రా అందరికి చూడండి. దాని తర్వాత number 3 is your spring force, right? And then gravitational force. For the droppers, not for 11th class students, okay? Second year students, లేదా droppers, there is electrostatic force. అదే కదా? So we're gonna study 6th one is your friction force. Right? Yes. So we're gonna study these natural forces ra. Natural forces ante enti? These forces exist by nature, by default. Ante kada? Right. Normal force, tension force, string force, spring force, all these forces. Sir, na దగ్గర ఒక block unte I'm pushing, it's not natural, right? It's my own force created. Ante kada? Let us talk about these forces now. So let us take questions. So questions nunchi let us try to understand. Okay? The first thing is that I'll give you a scenario. చూసుకోండి అందరికి. Same. Newton's laws of motion. గుర్తుందా? Passing of the forces, normal forces, contact forces. Good, very good. So sir, this is 50 kg of block. 15. And this is 5 kg of block. అంతే కదా? Right. So let us say there is this 80 Newton force. This is my 80 Newton force that is acting. Okay, yes. So the question is, I want to find the normal, I have to find the work done by the normal force. Normal force, normal force, sir? Normal force between the two blocks. Right. So the question is, find work done by normal force, చూసుకోండి, by normal force in first 4 seconds. చెప్పండి అందరికి. సో దీనికోసం నాకు నార్మల్ ఫోర్స్ కావాలి కదా? ఎస్. హౌ డు ఐ ఫైండ్ నార్మల్ ఫోర్స్ రా? హౌ విల్ యూ ఫైండ్ నార్మల్ ఫోర్స్? హౌ టు ఫైండ్ నార్మల్ ఫోర్స్ సార్? సార్ నార్మల్ ఫోర్స్ ఫైండ్ చేయడానికి we have completed Newton's laws. We have completed it. Good, very good. Very good. Acceleration is 4 meter per second squared. అంటే hunger of this block is 60 and this hunger is 20. అంతే కదా? It will receive 80, eat 60, remaining 20 it will transfer. So it is my normal reaction. Very easy. Hunger method, only 2 steps, answer completed. Finished. Ante kada? Right. Normal reaction is 24 Newton. So sir, normal is equals to 20 Newton. Normal ante force kada? Yes. So sir, force is equals to 20 Newton. Ochindi kada? Good. What about displacement? Displacement is what? What is displacement? No. Not in this case. Normal reaction on the wedge. The wedge is mg cos theta, not here. It's a very simple process. For the students who did not understand how did I write hunger and all these things, go and watch my Newton's laws. Over entire internet, you will not find that explanation. So if you are trying to understand this concept by looking some other expert, you will not understand. Okay? So that is my special trick. I will only tell, nobody will tell you. Okay? Yes. So F is equals to 20 Newton is the normal reaction, right? Put displacement guరించి చెప్పండి. How will you find displacement, sir? S is equals to ut plus half at square. అదే కదా. U value 0 ra, gone. Displacement is equals to half into acceleration intara. Acceleration 4. 4, right, Gonat? Yes, acceleration is 4 multiplied by t squared. First 4 second ante 16. అదే కదా. So it is equals to 32 meters is my displacement ra. Force is 20, displacement is 32. Ante work done is equals to F bar dot S bar, not Fs. Not Fs, F bar dot S bar. Always be careful, ra. ఈ situation లో force and displacement are in the same direction. Coincidentally, that is why you can simply write Fs. కానీ usually you must write F bar dot S bar అంటే F into S. అదే కదా. Not bar ra. F into S. అంటే force is 20, displacement is 32 అంటే 640 joule of work is being done by the normal reaction. అదే కదా. Work is 640 joules. This is the work done. Good. Very good. Very good. Very good. Very good. I want to talk about a little discussion, point of discussion. Okay, I want to talk about a little point of discussion, conceptual discussion. If you are ready, okay, if you are ready, I want to talk to you about a little conceptual discussion. Chuskondi. This is a wall, this is a ground. Okay, idan wall and this is my ground. Okay, and just next to this wall I am placing a sponge. Sponge telusara, sponge. So this is my sponge. Andariki chuskondi, ide na sponge ra. అంతే కదా. Let us say mass of this sponge m is equals to 1 kg. Okay, 1 kg of sponge is there. చూసుకోండి. So this is my finger. Okay, this is my finger. Hey, this is my finger. This is my finger. I'm pushing it. Let us say F is equals to 2 Newton is the force applied. What do you think will be the work done? Right, displacement cheppura, not work done. Displacement is how much? Displacement is how much, sir? What is there? Displacement is how much? What is the displacement of the sponge? Cheppandi andariki. What is the displacement of the sponge? The class will go on till 9 or 9:30, right? 9 or 9:30 p.m. So morning 9 to evening 9. చెప్పండి అందరికి, what is the displacement? Displacement is 0, sir. 0 kada. Hey, when I'm pushing the sponge, what is displacement? Displacement is 0. What is displacement? When I'm pushing this sponge ante telusa, sponge, do you know sponge ra? To explain you the sponge. Yes. So the displacement is 0. The displacement is 0. Not 0. Not 0. Chuskondi. Displacement is not 0, ra. Okay, not 0. When you talk about work done, in the formula W is equals to F bar dot S bar. Chuskondi. W is equals to F bar dot S bar. Ee formula lo S is the displacement of point of application of force, ra. Not of the object. No, not of the object. Okay, yes, it squeezes. It is the displacement of point of application of force. Displacement of this point. Okay, it's moving, right? Squeezing and it is moving. And the displacement is happening. It's not 0. Okay, S bar is the displacement of point of application of force. Ade kada? Yes. Point of application of force. That's it. So this is my work done formula. Okay, good. Good, Janvi, very good. If you know it, well done. If you don't know it, I'm here. If you don't know it, I'm here to explain. Chapman. Next question. Teeskondi andariki. చెప్పండి. వర్క్ డన్ బై ఫ్రిక్షన్ ఫోర్స్. వర్క్ డన్ బై ఫ్రిక్షన్ ఫోర్స్. What is the work done by friction force rate? 200.4. Good. Let us see. Let us see. Pravalika, very good. Friction force 40. Chudandi. Okay. Good. So first of all, sir, work done by friction force is nothing but F bar dot S bar. Point number one. You observe these things. First of all, these should be your first priority. You can find friction. No problem. You can find displacement. No problem. Kani direction of force choose when the object is moving towards the right. Friction always acts in the direction opposite to the motion on the left side. To the left side. Good. So the direction of friction force is the left side. Displacement? Cheppandi. Right side kada? Yes. And displacement in the right side. Idena S bar ki direction, idena F bar ki direction. Opposite అంటే angle is 180 degrees. Angle 180 degree unte work done is negative. Okay, work done is negative. F bar dot S bar ante F into S into cos 180 ra. Cos 180 cheppandi. Cos 180 value enti ra? -1. So sir, minus F into S. Work done is absolutely negative. Chuskondi. Ante the energy of the system is going to decrease. Ade kada. You remember positive work, negative work I told. Positive work unte energy of the system increases, negative work unte decreases. Ade kada? Right. Cheppandi. So now first of all I have to calculate friction force. Ade kada? Yes. Sir, friction force F is equals to mu into N. Ante mu into mg. Ade kada? Yes. Sir, mu value is 0.4, mass 10, G10, ante 40 Newton friction force. Ochindira. Got it. Ippudu we'll try to find the displacement. Sir, displacement ఎలా find చేయాలి sir? Final speed 0. Initial speed 20. Acceleration there. Yes, acceleration is there. చూసుకోండి. Friction force ra. Friction force is equals to mu into m into g. అదే కదా? Yes. Sir, force by mass. Acceleration is force by mass kada? Yes, force by mass. M got cancelled ra. So acceleration is equals to mu g. కానీ negative acceleration. ఎందుకు sir? Velocity in the right side, force in the left side, and acceleration in the left side, negative acceleration. What will you use, right? We'll use v square is equals to u square plus 2as. U square ante 0, ade kada? V square value step and no. Not u square. V square is 0, right? V square is 0, okay? V square is 0, right? Yes. V square is 0. U square value intara. U square is 20 square ante 400. Minus acceleration is negative. Kabatti minus sign. Chuskondi andariki. 2 multiplied by acceleration ra. Acceleration value mu g. Mu enta 0.4. G 10. Acceleration minus 4 into S. Ade kada? So sir, 400 is equals to 8 into S. Ekkadi nunchi S is equals to 400 by 8 ante 50 meters ra. Ade. So this is the 50 meter of displacement. Andariki cheppandi. Yes. Displacement 50. Force 40. Work done in that. Sir, work done is equals to minus of force is 40, displacement is 50. Ade kada? So that means negative 2000 joule. This is the work done. And this much of energy is gone. Now I'll show you one good thing. Okay? ఇనీషియల్ ఎనర్జీ క్యాలిక్యులేట్ చేసుకోండి రా. ఇనీషియల్ ఎనర్జీ తెలుసా? ఇనీషియల్ ఎనర్జీ how much sir? Sir, it only has kinetic energy. I'm telling you, you believe it. This guy, this block now only has kinetic energy, and formula for kinetic energy is half mv square. Okay, half mv square. చెప్పండి sir, initial energy ei is equals to half mv square అంటే half mass ఎంత 10, v square అంటే 20 square is 400 కదా. yes, so you 2 ones are 2, 2 2s are 4, 0 0, 200 into 10 is equals to 2000. Initial energy is 2000. మొత్తం 2000 waste రా, gone in work done కదా. yes, so that is why work keeps significance. అంటే in physics work is something that can be converted from energy, లేదా work is something that can be converted to energy. Are you understanding? Yes, great. So that means sir, initially this guy had 2000 joule of energy. Total energy has been eaten by friction force. చూసుకోండి, work done in the form of work done. It has completed or it has converted in the form of work done. అదే కదా, right? Good, very good. Work done is equals to energy. So that means you had 100 rupees in your pocket. You brought the biscuits of 100 rupees. So మొత్తం money transferred into the biscuits. అంతే కదా, total energy transferred into the work done. So final energy ఎంతరా? Final energy is total initial energy minus work done. 0. చూసుకో, v is also 0. half m v square, 0 square 0. అదే కదా, complete energy is gone. next తీసుకోండి. చెప్పండి. అందరికి వర్క్ డన్ బై టెన్షన్ అంటారు. హౌ టు క్యాలిక్యులేట్ వర్క్ డన్ బై టెన్షన్ రా, చెప్పండి. స్టార్ట్ ఫ్రమ్ ద బేసిక్స్. బేసిక్స్ అంటే ఏంటి సార్? బేసిక్స్ అంటే వాట్ హ్యాపెన్ టు యూ రే? Not responding. What happened today? You know, all the technical problems are coming on my head only. Okay, I'm writing, it's not writable. It's writable. Yes. Hey, చెప్పండి. Sir, W is equals to F bar dot S bar. S bar, displacement of point of application of force. Okay, no, displacement of point of application of force రా. చెప్పు. సో అంటే టెన్షన్ ఫోర్స్, టెన్షన్ ఈజ్ యాక్టింగ్ అప్, ఎక్కడ కూడా పైనకి యాక్ట్ చేస్తున్నారు. అదే కదా, పాయింట్ ఆఫ్ అప్లికేషన్ చెప్పండి. వేర్ ఈస్ ద పాయింట్ ఆఫ్ అప్లికేషన్ సార్? సార్, పాయింట్ ఆఫ్ అప్లికేషన్ ఇస్ దిస్ అండ్ దిస్. అంటే రెండు పాయింట్స్ ఆఫ్ అప్లికేషన్స్ ఉన్నాయంటే రెండు డిస్ప్లేస్మెంట్స్ ఉన్నాయిరా. దట్ మీన్స్ దెర్ విల్ బి 2 different directions, 2 different values of work done. అదే కదా, ఎస్. సో దట్ మీన్స్ దెర్ విల్ బి 2 different values for work done. So let us talk about each and every case in detail. చూసుకోండి. Actually this question is not correct. ఎందుకంటే I have to find work done by tension. On what? Tension is applying force on 2 blocks kada. On which block? Work done by tension on 3 kg block. Work done by tension on 7 kg block. Are you understanding? So let us calculate separately. Number 1 on 7 kg block. అందరికి చెప్పండి. Seven kg block. Where is it moving? Up. Where is tension acting? Up. Same direction. Theta value 0. అదే కదా? Yes. Sir, 7 kg block ante tension in the upward direction, displacement in the upward direction, ante theta is equals to 0, work is equals to F bar dot S bar ante Fs cos 0. Ade kada cos 0 value 1 ante F into S. Finished. Sir, tension value, do you have it? Do you have it? Yes. Formula for tension in Atwood's machine. Gurdunda, I told you to remember this. Specifically, I told you to remember tension value. Directly cheppandi 2 m1 m2 divided by m1 plus m2 multiplied by g. Hey, you remember this? Yes, cheppu. 2 into m1 value 3, m2 7 divided by 10 into 10. Ade kada? So 7 3s are 21 into 2 becomes 42 Newton is the tension value. Force ochindi. Ippudu displacement kavali. Displacement calculate cheyadaniki you need acceleration. Half 80 squared. Ade kada? Yes, you need acceleration. 30 kg is not there. Go not, where is 30 kg? 30 kg mass is not there. 3 and 7 kgs are there, right? Tension is 42 Newton, 1 not 140. Formula, you remember formula. Tension is same for both the blocks. Both the blocks, tension is same. Okay? Good, good, good. Hey, acceleration cheppandi. Acceleration is, sir, m2 minus m1 divided by m1 plus m2 into g. Ade kada? m2 minus m1 how much? 7 minus 3, 4. Divided by m1 plus m2 is 10 into 10 ante 4 meter per second square. Idena acceleration ra. Naku displacement kavali in how much time? 4 seconds ra. 4 seconds. S is equals to half 80 square kada? Yes. Sir, S is equals to half acceleration 4 t square ante 4 square, that is equals to 32 meters. Ekkada kuda same displacement ra. Last case just like previous case kada, friction force. Same displacement, force is different. Now you want to calculate about the work done. Cheppandi andariki. Work done simply F into S kada. So here W is equals to force how much? Tension force 42 multiplied by displacement how much? 32. Ante kada. Cheppandi 32 into 2 becomes 64. 6 is carried. 32 into 4 becomes 128 plus 6 ante 130. So 1304 joule of work done is on the 7 kg block. Ade kada. Are you understanding this? 1304. Okay, 1304. Good, good. Now let us calculate work done on 3 kg block. Andariki cheppandi. So this is my 3 kg block. The problem is it is going down 7 kg. This is my 3 kg. Ante kada? Hey. Did I do some mistake, Ray? Hey, theta is not 0, Sarji. Theta is not 0. Theta is 180 degrees. Chuskondira. How can you not correct me, Ray? When I am doing some mistakes, it is your responsibility to correct me. Ante kada? So, sir, 7 kg is not going up. Kindagi veltundi, sir. Tension paina. Object kindagi veltundi. Ante angle is 180 degrees. 180 degrees. Chuskondi. My dear respected students, angle is 180 degrees. Ante Fs cos theta ante Fs into minus 1. Andariki. Cos 0, it's not cos 0, it's 180. Okay? It's minus 1 ante minus Fs. Remaining everything remains the same. Only a negative sign comes into it. Ante kada. Good. Let us talk about 3 kg. It is coming up, Ray. Tension is also up, Ray. Ante ippudu the angle is 0. Ee scenario lo. So if theta is 0 andariki, theta is equals to 0, W is equals to F bar dot S bar ante F into S into cos theta ante cos 0 ante F into S. Ade kada. Tension force remains the same. Andariki chuskondi. Tension force does not change. Tension force is 42 Newton only. Displacement is also 32 Newton. Kani it's in the upward direction, it's in the downward direction. It goes something like this, right? Chapo. So work done is equals to 1304 joule. Ante I'll revise it very quickly. Andariki chuskondi. Work done by tension on 7 kg block. Negative kada. Minus 1304 joule. Similarly, work done by tension on 3 kg block. Cheppandi andariki. This is also 1304 joule. When you talk about total work done, work done total by tension, it should be equals to addition of both of them. 1304 minus 1304 ante 0. Chuskondi. That is why the name is tension. This much of hard work and answer is 0. Okay. Chala tension unnayira. Okay. Who's there? So work done is 0. Work done by tension is 0. Ade kada? On the system, work done is 0. Okay, good. Next, work done by spring force. Andariki chuskondi. Okay. You understand this, You understand. This is my block. We talked about work done by contact force, work done by friction force, work done by tension force, work done by spring force. Ade kada? Dan tarvata gravitational is there, and lastly electrostatic is there. So we will quickly go through all of them and then we'll, yes, exactly. So this is my spring. Andariki chudandi. Okay, this is the block. Let us say the block is having some mass m. Andariki observe cheskondi. I'm telling you a very important thing now, okay? So let us say I'm giving some initial speed u to this block ra. Andariki k is the spring constant. Okasari initial speed is the block is moving towards the right. At the same time, the spring is getting elongated. Ante the value of x ante elongation kada. X is increasing. Choose now the biggest problem that I have. Biggest problem is spring force. What is the biggest problem, sir? Formula for the spring force. F is equals to k into x. Actually direction is negative. You remember k into x. Finished. Force in the left side. Displacement in the right side. Force in the left. Displacement in the right. Andariki chudandi. Force left loner. Displacement is in the right side. Work done will be negative. Work done will be negative. Endukante opposite directions, force and displacement, angle is 180 degree. Work will be minus f into s. Ade kada? Force ki value em ravali ra? Okay, minus k into x. Displacement em ravali ra? Displacement, let us say, sir, you have displaced this from this to this, until let us say the displacement is also equals to x ray. X will be only the displacement ra, because the block has moved. Until whatever elongation has there in the spring, that will be the distance covered by the block. So it will be x minus kx square. This answer is wrong. Force into displacement is wrong. Endukante the force is not constant. Chudandi, force is kx kada. Kx formula lo x variable constant, right? It's variable. As the block is moving ahead, every time the value of x is increasing. Ante force is variable. Variable force unte em formula use cheyali? Variable force unte you can simply say, sir, work is equals to integral f dx. Ade understanding, that is integral kx dx ra. Limits are from 0 to x. Remember, okay, if you are understanding, if you are not understanding, just so you simply say, sir, k into x integral x to the power 1 kada? Yes, increase it ra, x to the power 2 by 2. Ade. So your final answer is kx square or half kx square at ide. So this is the work done by the spring force. Work done by the spring force. Ade kada? Yes, k is constant. Good. So this is the work done by spring force. Ippudu kosam, for now you remember whatever I am telling to you, okay? For now you remember whatever I am telling to you. For now. I will come to this later also. But for now, remember point number 1. Be it elongation, leda, it is compression. It is elongation or compression, irrespective of the nature. If x is the elongation, leda, x is the compression. Work done by spring will always be equals to half kx square. This very same work done will be energy stored in the spring. Chuskondi re. For now you remember, I'm telling you, okay? For now you remember, the same work done is storing energy in the spring. Ade kada? Yes, in the spring. Understand, this is a very important formula, okay? What is the potential energy of spring? Ante half kx square is the formula. Spring force kx, potential energy half kx square. Ade kada? Right. So So now let us talk about the gravitational force. Andariki chudandi. Gravitational force. So let us say the object is placed here on the ground. Ade kada? Yes. Mass m is there. Gravitational force mg. Chuskondi ra. Okay. Gravitational force mg. What you are doing is you are lifting this object. You are increasing the height of this object. You lift it to a random height h. Let us say you are lifting it up, and you got a random height h. Chapandi andariki. What is the work done by gravity? What is the work done by gravity? Chapandi andariki. Sir, work done is F bar or S bar? F bar dot S bar. Ade kada? Yes. Sir, work done is equals to F bar dot S bar. Chuskondi. F ante in the downward. S ante upward. Opposite direction. Angle 180 degree. Force negative. Okay. Force is work is negative. So force value anta mg into displacement anta height into cos 180 is minus 1 ante minus mgh. This is the work done. Okay. Negative work done ante entira. Energy is lost from the system. Ade kada? Right. Cheppandi andariki. So when it is released, work done is downward, displacement is in the downward direction. So you are lifting it up. Okay. In case you are lifting, so work done is negative. Okay. Now you are moving it down and releasing. Directly work done is equals to F into S. Same directions kada. mgh. Ade. This is the work done. Finished. Gravitational work done mgh. Spring work done half kx square. Very good. Very good. Got it. Very good. Okay. Tension force, work done by tension force. Atwood's machine, you remember, always remember, it has been asked in a single line questions. The work done by the tension in Atwood machine is 0. The work done in tension in Atwood's machine is 0. Ante kada? Right. Good. So now let us talk about, leave about electrostatic force. Okay? Leave about electrostatic force. Andariki. Chuskondi. So now let us move a little bit ahead, or if you want, let us discuss some PYQs. Okay? Good PYQs. Discuss the one. Perfect. తీసుకోండి అందరికి an object moving along horizontal x direction. Negative work decreases the energy of the system. Negative work decreases the energy of the system. Okay. I want to write it, Karthik, so that you read it while I am writing. Everybody read it while I am writing. If it's a typed question, you will not even see. At least you will get curiosity when I am writing it. Okay. Chapani andariki. So, sir, kinetic energy 10. Ante initial energy is equals to 10. Ade kada? Yes. So, that is equals to 10 joule. Dan tarvata displaced through 3I meter. Ante displacement is in the right side. Chuskondi. Displacement S bar is equals to 3I cap. Force in tara, force is equals to minus 2I plus 3J. Ade kada? Chapandi, work done ra. Work done. W is equals to F bar dot S bar. Ade kada? Only multiply I with I. Ante minus 6 I cap. No, not I cap. Right? Minus 6 joule of work has been done. Negative work. Negative work. Negative work. Ante kada? Negative work. Energy decreases. How much decreases, sir? Minus 6 joules. Ade 10 was there. Minus 6 gone. 4 joule is remaining. Are you understanding? Next. Next. Let us talk about energy. Andariki. Or let me see if such type of questions are there. Okay. Power. Okay. All right. So let us talk about energy. Chuskondi andariki. Okay. What no, sir? You're not understanding, Gonat. You did not understand it. Okay. Did you understand work done? Did you understand displacement 3I cap? Force is minus 2I plus 3J. W is equals to F bar dot S bar. You understand this? How do you multiply 3I plus 0J kada? Yes, dot product. Dot product cheyadaniki you multiply I with I, J with J. I with I ante minus 2 into 3, minus 6. 3 into 0, 0. Ante my work done is minus 6 joule. Ade kada? Positive, negative work. Work is positive, negative. It's a negative work. So negative work unde it decreases the energy of the system or increases the energy of the system? Not 6. Yeah, dot product baba. F bar dot S bar. Chuskondi. F bar value enti minus 2I plus 3J kada dot 3I plus 0J. 3I only. You multiply I with I. This is how the dot product is done. You go and watch my vectors video. Okay, I explained there in a very good amount, in a very explained detailed way. Okay, you watch vectors. So I with I multiply for dot product. This become minus 6. Okay. Next, hey, I was talking about energy. Okay, I was talking about energy. We will take a break on 6:15. Okay, we will take a break of 6:15. So break will be 6:15 p.m. to 6:40 p.m. 25 minutes. Give me some extra time also. Okay? I am also a human being. I also need some rest. Chappandi andariki. So let us talk about energy. Energy gurunchi maatladtam andariki. Chappandi. What is energy, sir? Energy is the definition. I am telling you the definition. Chuskondi. The capacity to do the work. Everybody knows. Everybody knows. Yeah, it's okay. Hi, Vikshita. I know your name, Vikshita. I know. Okay, you told it at least 4 or 5 times. So, energy is the capacity to do the work. They say like this, okay? Kani, what I say, energy is money. Energy is money. What about work? Work is chocolates. Energy is money. Work is chocolate. And you can convert energy into work or work into energy, interconvertible forms. You go to shopkeeper, give 100 rupees, bring a chocolate. Come to house, see it, take picture, go back, tell him, no, I want my money back, give it. Okay? Energy is money. Okay? Energy is money and work is chocolate. Best example I'm telling you. Okay? Best, yes. Yeah, dairy milk. Ade. So energy is money and work done is chocolate. So you understand, okay? You understand. Energy lo kuda rendu rakala energy unnai ra. The first one is the kinetic energy of the object. Okay? What is all this issue, sir? I'm getting too much headache, sir. Kinetic ante enti, sir? Potential ante enti, sir? I'll explain. Don't worry, Baba. I'll explain, okay? Potential energy and kinetic energy. Andarki chudandi. Kinetic energy and potential energy. How many of you know the kinetic energy definition? Andariki. How many of you know the definition of kinetic energy? Yes, work plus energy is equals to money chocolate. Right. Right. You imagine, you are sitting in your room, you're not able to sleep, 2 a.m. at night. At night, 2 a.m. is the time. Okay? And suddenly, you saw that movie, Arundhati. Arundhati, yes. You saw that movie, Arundhati, at 2 a.m. in the night. And suddenly, the water bottle in your room shifted up. Okay? It has been lifted up. And it is moving. Slowly, it is coming towards you. This bottle, slowly, it is coming towards you. Something like this. Okay? Something like this. It's coming towards you. What will happen? Yes. What will happen? First thing, sir, we will not stay in that room. Some students may find that their mattresses may become hey, you're understanding what I'm telling? Heart attack, right. Why? Because a bottle suddenly got kinetic energy. Understanding? The bottle suddenly got kinetic energy. Sir, every moving object has, whatever the object is, wherever the object is, whenever the object is, whenever it is moving, it has energy. You close your eyes and tell. If it is moving, it has a kinetic energy. If it is moving, it has a kinetic energy. Mass does not matter. Even the gas particles దగ్గర కూడా kinetic energy ఉంటుంది. You can find that by using F/2RT. That's thermodynamic process. మొత్తం different scenario. Okay? But you understand. For now, if you have any moving object, అంటే it's a non-living thing, Your biology, basic classification kada. Living, non-living. Non-living things do not have energy, They do not have it. Understanding? I am a living object. I am standing. Suddenly I started talking. There is inside energy. Energy is there. Where did it come? Energy is there. Okay? Energy is there. That is why you are not feeling surprised. If this pen suddenly moving, you will feel. Okay? So when this pen is moving, you will feel that it is a non-living thing. It should not have energy. So what happened? Cheppandi. First thing. It cannot do anything by itself. Ante kada. First thing, this pen cannot do anything by itself. It needs an external agent. Chuskondi. Ee pen ki oka external agent kavali andariki. So when this external agent lifts it, it is moving. Ante kinetic energy has arrived. Okay, kinetic energy ochindi ra. Okay, the kinetic energy has come. What are you talking, Ray? So a moving object suddenly got energy. That energy is known as kinetic energy. And every moving object in the world has some energy. Kinetic energy formula ఏంటంటే half mv squared. అదే finished. Potential energy. To tell you in simple words, you imagine like this. Potential energy is a form of energy that is just stopped until you release it. The potential energy has the potential to convert into kinetic energy. What I'm telling? What I'm telling? Hey, what I'm telling? Yes, yes. The potential energy is the energy stored in the object by the external agent. And you just release it. Potential in the sense there must be stopping force, some external stopping force. So this pen is there, Rachusko. I am holding it, my fingers are applying force on it. As soon as you release it, moving, spring, తీసుకోండి, extend, hold it. As soon as you release, motion, rubber, pull it, hold it. As soon as you release, motion, same process. Understanding charges, charges, positive, negative, attraction, hold it. Energy is there between these two. Release it, motion. Potential energy ante, potential energy is a form of energy that could be converted into kinetic energy if it is released, and if it's not held or held by any other object. చూసుకోండి. So potential energy plus kinetic energy are the two forms of energies. So ఇప్పుడు the value of potential and kinetic energy, the value of potential and kinetic energy depends on different forces. For example, చూసుకోండి. Potential energy is only defined what are you talking, sir? What are conservative forces and all? I'll explain, don't worry. Okay? Next. Before that, before this, let us take a question. చెప్పండి అందరికి. Anyone listening to me? చెప్పరే బాబు, చెప్పు. Sir, if the object is released from 500 meters, చూసుకోండి. Kinetic ఏంటి ఫార్ములా? కైనెటిక్ ఎనర్జీ హాఫ్ mv స్క్వేర్ కదా? నో, హాఫ్ mv స్క్వేర్. గుడ్ గోనట్, వెరీ గుడ్. v అంటే what? స్పీడ్. వాట్ ఈస్ ద ఫార్ములా ఫర్ స్పీడ్ రే? root 2gh. Yes. So sir, kinetic energy 1 is equals to half mv1 square. K2 is equals to half mv2 square. అదే కదా? రైట్. రేషియో తీసుకోండిరా. సో సార్ k1 by k2 is equals to v1 by v2 whole square. అదే కదా? Yes. v1 value root 2g, half distance అంటే h by 2 divided by root 2g complete distance h whole square రా. root 2g gone. Okay? So root of h by 2 divided by root h whole square. And very good. Next. No PYQs ra. Okay, you take this. Okay, this is 2015 question. చెప్పండి అందరికి. హాయ్ హాయ్ హాయ్, హలో స్పందన, హాయ్. చెప్పండి రా. వర్క్ డన్ చెప్పురా. Hey Teja, it's your problem, Ray, not my side. You check your internet connection properly. Everything is clear. Rest, everything is clear, ra. 500, huh? 500 option is there, not 500. Okay. Right, good. ఇనీషియల్ కైనెటిక్ ఎనర్జీ Ki is equals to half mu square అంటే half into mass 10 అంటే u square అంటే 100 అదే కదా, సో 500 joules. గుడ్. సో ఇనీషియల్ కైనెటిక్ ఎనర్జీ is 500. ఇప్పుడు if you have to change the kinetic energy, work must be done రా. అదే kinetic energy money, work is chocolate, you have to change it అంటే you are converting kinetic energy into work లేదా work into kinetic energy. The only difference is positive work unte energy increases, negative work unte energy decreases. Ade kada? Good. Good. Very good. Very good. So now, sir, work is equals to integral f into dx. Enduku integral f dx ra variable force. Chusko 0.1 into x. X is a variable. Ade kada? Till x is equals to 20, no force ante no change in kinetic energy ra. Ade kada? No force, no work. No change in kinetic energy till x is equals to 20. 20 నుంచి 30 వరకు there is some force అంటే change in kinetic energy will be there రా. So put the limits as 20 to 30. అదే కదా? Yes. F value substitute రే. 0.1 into x dx from 20 to 30. Okay? That means 0.1 into integral x is x square by 2 అందరికి చూసుకోండి. అదే కదా? 20 to 30. Substitute the upper limit then lower limit రా. So 0.1 into upper limit 900 by 2 450 minus 400 by 2 200 అంటే 0.1 multiplied by how much రే 250. So that is equals to 25 joules. అదే కదా? పాజిటివ్ నెగటివ్ వర్క్ రే. వర్క్ డన్ రా. రిటార్డింగ్ ఫోర్స్ అంటే ఫోర్సెస్ నెగటివ్ minus 25 joules. So initial there was 500 రా. దీనిలోంచి minus 25 joules gone in the form of work done అంటే your kinetic energy final is equals to 500 minus 25 అంటే 475 joule. అదే రైట్. ఇప్పుడు let us talk about types of forces. జాగ్రత్తగా చూసుకోండి రా. టైప్స్ ఆఫ్ ఫోర్సెస్. నంబర్ 1, types of forces. Number 1 రా కన్సర్వేటివ్ ఫోర్స్ చూసుకోండి. And number 2 రా it is non conservative force. Sir, what is conservative and non conservative, sir? గుడ్. చూసుకో. Conservative force అంటే ఏంటి సార్? In short words, I'm trying to tell you the definition in very easy words. Okay, చూసుకోండి. First let us talk about similarities. Okay, let us talk about similarities. అందరికి both of them they will do work for sure. Both of them they will do the work. Okay, does the work absolutely. He also does the work. అదే కదా? Understanding? But చూసుకో. Hey, you understand this? Okay? No, not displacement. Okay, you can say that work is path dependent. You're not talking about displacement, you're talking about path dependent and path independent forces. It's a little complicated definition, but I'm trying to simplify it for you. Okay? Hi Spandana. Hi. Conservative forces doing work, definitely doing work. Kani, but it does work to convert one form of energy to convert one form of energy in another form. Ade. That means the total energy is conserved The total energy of the system is conserved. అదే కదా? Yes. So that means this guy is a trustworthy guy. Okay? You are giving your money to him, but he is bringing same amount of chocolates. You are giving energy, same work is done. To convert one form into another form, understanding work it is doing for sure, 100% he is doing work. But the work done is used to convert one form to another. One form to another ante enti ra? Kinetic to potential, potential to kinetic. Ade. Are you understanding? Good. You are again going into much complicated definitions, ra. Yes, answer is correct. I'm not telling your definitions are wrong. They are complicated. What do you mean by, sir, work done depends on the path? Work done depends on, does not depend on the path. Path independent, path dependent. Too much complicated. You remember these definitions. Okay, you remember these definitions. Okay, here, ekkada vachi cheppandi. It does work to change the energy. Okay? To change the energy, to change the energy of the system. Chuskondi. Conservative forces, they do work for sure. Conservative, non-conservative, both are doing the work. Okay, both are doing the work. But the work done by conservative force is staying in the system only. Okay, he is our guy. It is our home money. He is in the home only. Money is in the home only. Understanding? But here he is stealing the money. Stealing the money and stealing the energy. It will change the energy. So jagrataga chuskondi. If you are giving responsibility to conservative force, if you are giving your responsibility to conservative force, it will be a very sincere, no, trustworthy guy. Okay, he is a very trustworthy guy. This guy is a thief. Okay, this guy is a thief. Thief and he is stealing the energy. Examples choose for examples. Example is the friction force. Best example. Okay, best example. Best examples are your gravitational force or spring force. Okay, your spring force, your gravitational force, okay, your electrostatic force. Electrostatic force, gravitational force, spring force. These are the examples. Ade kada? ఇప్పుడు one by one చూద్దాం రా. కన్జర్వేటివ్ ఫోర్స్. ఓకే, కన్జర్వేటివ్ ఫోర్స్ does not change the energy of the system. You understand it, okay? Does not change the energy of the system. Yes. So you can simply say conservative force. Simply the name ra conserves the energy. Ade kada? Yes. So if you have the total system in the kinetic energy and the potential energy you form ra, okay, you are taking some energy, throwing there, work is done. Ade. Lega, you are taking some energy, throwing there, work is done for conservative force. Conservative force. So work is done only to change the form of energy, not the energy by itself. Until you can simply say, you understand. You can simply say, if we are talking about mathematical terms, okay? Initial energy must be equals to final energy. Ante enti ra? Ante enti? Initial energy lo kinetic potential unnai kada? So initial kinetic energy plus initial potential energy should be equals to final kinetic energy plus final potential energy. Mari work, sir? Where is the work gone? To change the values, re. Ade, you are understanding? Are you understanding? Yes. I'll explain you everything. Okay, I will explain you everything. Chuskondi. Examples of conservative force ra. Cheppandi. The best example is your spring force లేదా your gravitational force రా. చూసుకోండి, అదే కదా. your gravitational force. Andariki work done is utilized to store one form of energy into another form. Ante kada. So when I'm talking about spring force, you remember I told you potential energy of the spring is half kx square ra. Chuskondi. Ade kada. Here gravitational potential energy is given by mgh. All of you. I want you to be understanding these questions very perfectly. Are you understanding this? Are you understanding all of this? Cheppu. So now let us take one by one ra. Let us talk about gravitational force. Chuskondi andariki gravitational force. Okay, let us say I am dropping an object. Andariki chuskondi andariki all of you. What should I say? The object of mass m is released from a building of height h ra. From a building of height h. Now final speed kavali ra. I want the final speed. V is equals to what? I know it's root 2gh. I know, but I want to do it this way. I want to do it this way ra. Chappu. You analyze which force is acting re? Gravitational. Gravitational force is conservative, non-conservative? Conservative force. And it is doing work. For sure it is doing work. Gravitational force is doing work. But where is the work going? To change the one form of energy into another form. And the equation enti ra? Equation is initial energy should be equals to final energy. Conservative force conserves the total energy of the system. And initial energy is equals to final energy. Ade kada. So if you're releasing or if you're picking the object at height h ra, cheppo. If you're lifting the object at height h, work done. How much? Work done. What is work done? Sir, mgh. Potential energy. Gravitational potential energy. Initial energy ante kinetic energy plus potential energy should be equals to final kinetic energy plus final potential energy. Ade kada. Initial kinetic energy cheppora. Just releasing ante speed 0. Half mu square plus potential energy initial mgh1 must be equals to half mv square plus mgh2. Ade kada. Yes, plus mgh2. Values cheppora. Values cheppu. h1 ante initial height ra. h. h2 ante on the ground. h2 is 0 ra. Chusko. h1 value h. Ekkadochi initial speed u value 0 ante it is gone. It is 0. And final speed ra. You have it. Okay. So what you say, sir? mgh is equals to half mv square. mm gone. Ante kada. 2 is division. Send your multiplication. So 2gh is equals to v square. Ante v is equals to root 2gh. Ade kada. These are the values for the formulas. Chuskondi. Okay. Nice. So the total energy is conserved in case of conservative force. Ante spring force, gravitational, electrostatic force. For you only 3 forces. You remember this. Always use this formula. The formula use cheskondi. All the times. For conservative force, all the times. Short, everything will be done in this form. Are you understanding? Yes. Hi Nandini, hi. Okay. Next. Let us talk about spring force. Spring force. Okay. Spring is you understand something like this. Okay? So idena spring ra. And this is a block. Mass m, speed u ra. Andariki cheppandi. Gone, right? Buffering is gone. We'll solve this question and take the break, Ra. Okay? Yeah, there is some network problem, all of you. It happened in the last class also, Ra. Cheppandi. Sir, speed is there, energy is there, kinetic energy. Kinetic energy. Yes, kinetic energy is there initially. Initially, there is kinetic energy. Kachitanga, there is energy, Ra. 100%. Okay? What is the initial energy and what is the final energy? I have to compare it. I have to compare it. Nandini, I have been teaching from 9 a.m. in the morning. You are telling no break. How is it possible? Okay? Choose kodi andariki. So, which force is there? Ra? Spring force. Conservative, non-conservative? Conservative. Close your eyes. Conservative force unte okate equation use cheskondi. What is the equation, Ra? Initial energy must be equals to final energy. I will tell you a shortcut also. Daniki tarvat. I will tell you shortcut. But Nandini, this session will be till 9 p.m. 9 p.m. 9 or 9:30, I don't know. It will for 9 p.m. or 9:30 p.m. I don't know. Okay, one shot is there. Chalo. So, energy initial should be equals to energy final. Energy initial ante rendu types. Cheppandi. Initial kinetic energy plus initial potential energy must be equals to final energy ante final kinetic energy plus final potential energy. Ante kada? Yes. Final kinetic plus final potential. Good. Substitute. If you just substitute the values. So this is the only equation that you have to do all the works. Initial kinetic energy is half mu square. Ade kada? Plus initial potential energy. Potential energy of what? Spring. What is the formula for potential energy of spring? Half kx square. X value entida? Initial situation lo, what is the value of x? Zero. Ante initial potential energy is 0. Is equals to final kinetic energy gurinchi cheppandi. When it is hitting the spring, maximum compression aindi kada. Ee moment lo the block is momentarily stopping for some time. Okay? The block is stopping for some time. Ante final kinetic energy in that instance, it is 0, half mv square. V 0 kada plus potential energy final is half kx square. Chuskondi. Final potential ante compression kada. Be it compression leda elongation. X compression, X elongation. Rendu cases lo potential energy is given by half kx square. And equate both of them. Half mu square is equals to half kx square. Gone. Mu square is equals to kx square. Directly rastunaru chuskondi. Maximum compression is the root of mu square by k and u root of m by k. Ade kada? Yes. Okay? This is the maximum compression in the spring. Ardhamaindi? Right. So now let us take a break. What is the time, right? 6:20 kada? Yes. Okay, then we will be completing with our sessions, including PYQs also. Hello everybody. So then after the break. Yes. Okay, perfect. Perfect. So let us see. Let us see all of you. All of you. Right. Gonat, in what case are you talking? W is equals to U and nt. I'm not understanding your scenario. Okay? I came on exact perfect time. Okay? 6:45 only. Okay. So let us go and let us solve the questions. Now, Gonat, I did not understand. What are you talking? In what context are you talking? W is equals to U and work is equals to potential energy or what? Oh, okay. 1 minute late, right. Chapandi Andash. Hey, now let us try to understand a few things, okay? Before solving the question. Yes, very good. Gonat, yes. In gravitational, work is equals to negative of potential energy stored. Very good. I'll explain you, okay? I'll explain everything. Choose the only thing that you have to do is look at me. Okay. Next, చూసుకోండి రా. So let's just quickly revise. Okay, let's just quickly revise. Okay, let's just quickly revise రా. చూసుకో. Gravitational potential energy. Gravitational potential energy. అంటే ఏంటిరా? Gravitational potential energy అంటే ఏంటి? చూసుకోండి. So you have two different cases. Okay, రెండు cases ఉన్నాయిరా. The first case is you're lifting the object. Okay, you're lifting the object, and the object is here. You have lifted this object to a certain height h ra. చూసుకోండి అందరికి. ఈ సినారియోలో మాస్ m ఉంటే the gravitational potential energy increases. Point number 1. Andariki, whenever you are lifting it, you are increasing the potential energy. Ante kada? Yes. So basically, when you are lifting it, ante for lifting purpose ra, cheppandi. For lifting purpose, gravitational potential energy increases. Always remember, okay? Always remember this. Similarly, when you are keeping it down ra, kindagi tisi automatically, okay, for keeping it down, what happens ra? For keeping it down, the gravitational potential energy decreases. Ade kada? Yes. What about work ra? Chudo. When I'm talking about work, there are two people. There are two agents. Rendu agents unnai. Rendu agents ante rendu forces unnai ra. The first force is the gravitational force by itself. Andariki chudandi. So when I'm talking about gravitational force ra, ekkada gravitational force kindaki act chestunnaru kada? Yes. Displacement ekkada ra? Painaki. Until the gravitational force is doing a negative work. Point number 1 to be noted. Okay. Yes, absolutely. Go on. Gravitational force can store the energy. Gravitational potential energy. Spring force can store the energy. That's what I'm telling. Conservative forces. All the conservative forces, they can store the energy within themselves. Ante kada? Yes. Okay. Good. Very good. So basically, when you talk about work done ra, వర్క్ డన్ సినారియోలో గ్రావిటేషనల్ ఫోర్స్ అంటే కిందకి యాక్ట్ చేస్తున్నారు, డిస్ప్లేస్మెంట్ పైనకి ఉంటుంది కదా. అంటే వర్క్ డన్ బై గ్రావిటేషనల్ ఫోర్స్. చూసుకో, వర్క్ డన్ బై గ్రావిటేషనల్ ఫోర్స్ work done by gravity is negative when you are lifting it. When you are lifting it, work done by gravity is minus mgh. Kani, who is lifting it? External agent. Choose. So the external agent is pulling it up. Displacement is also up. That means work done by external agent is positive. Ade kada? Yes. Yes. It is work done by external agent ra. Choose kondi. External agent. How much ra? Enta work? Same work sir. mgh. Kani it is a positive work. Ade. Work done by gravity is negative. Work done by external agent is positive. Either positive work done by external agent is stored in the form of gravitational potential energy. Negative energy vachindi kada. So it is not happy. Endukante there is a burden on him. Depth. Depth. Telusa? Depth ra. What is Telugu? What is Telugu word for depth? It is a depth on it. Okay, depth. Depth ante Telusa? Okay, good. So basically, when the external agent is using his hands to lift the ball, when the external agent is using the hands to lift the ball, he is doing positive work for sure. And he is doing positive work. Kani, in mottam positive work, it is getting stored in the form of gravitational potential energy. So it is a depth. 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 What should you say, right? Depth. So it is a depth to gravitational force. So basically external agent is giving some depth to gravitational force. It is from my side. Ante kada? Okay. So whatever external agent is doing work, it is getting depth. Okay, up. Right. I knew it. So basically, all the work done by external agent is getting stored in the form of depth. Appu, ante potential energy. You understand? Potential energy is simply the depth. Loan. Okay, loan. Potential energy is nothing but the loan taken by the external agent. Ante kada? Similarly, in case of spring, chusko, spring, I'm pulling it and I'm extending it and doing some work. Yes, a work has been stored in the form of loan. Now, the gravitational force is a conservative force ante a very trustworthy person. It will return it for sure. Are you understanding? This loan, it will return it. Ippudu, you remove the hand. It is giving all the energy in the form of kinetic energy. Return. Finished. Ante kada? Good. Right. Next, chudandi. So when you are increasing the height of the object, gravitational potential energy ante loan on gravity increases. So what happens? You release it, it will release the loan also. It is giving all the energy back in the form of kinetic energy. Ade kada? Cheppandi andariki okkasari. No, it's a conservative force. Detail kavalira. What do you want detail ra? I'm telling this much detail and you're telling again to tell me the detail manner. Okay? So let us understand one thing. Okay, let us understand one thing ra. Na దగ్గర ఒక object of mass m ఉంటుందిరా. I'm throwing it vertically with the speed of v. చూసుకోండి. I'm throwing it vertically with the speed of v kada. Yes. So object is going up, speed is decreasing. At topmost point low, the speed is 0. Ade kada, v is equals to 0. Find the height ra. Find the height. Ante enti ra? Chusko. I'll explain you in a very basic way. Understand. Listen to me. Okay. Look at me. All of you. Andarki. Chudandi. Okay. Initially, the external agent throw it kada. Throwing ante energy giving ra. So this energy has been given to gravity. Loan. Enta loan icharu. How much loan did you give it? Sir, total energy is loan. Same energy ra? Kinetic. Initial energy is kinetic energy. Ade kada? Yes. So the total loan that you gave to gravity is this much. Ade kada? Now, all that loan is stored in the form of gravitational potential energy. Understanding it is the best way to solve the question. Conversion from one energy to another energy form. Kani, it is only valid for conservative forces. Are you understanding? So sir, మొత్తం kinetic energy has got converted into gravitational potential energy. Formula ఏంటిరా gravitational potential energy? You can simply say mgh. అదే conversion of one form of energy into another form. కానీ you must understand what is getting converted. Which form is getting converted into which form? అదే కదా kinetic energy completely converted to potential energy. Speed 0 కదా? Yes. Sir, mm gone. Sir, h is equals to చెప్పు. h is how much? h is equals to u square divided by 2g. అదే కదా? Yes. Direct answer. Okay? Okay. Not 0. Not half ray. When you're telling I want to calculate h, final speed is 0. For sure, final speed is 0. Can you h is this one? Okay. Similarly, చూసుకోండి. Next question, ra. Okay, next question. తీసుకోండి. An object is thrown up. Not up. I should not say up actually. An object is thrown as shown. Full stop. Find maximum compression in spring. చెప్పండి అందరికి. Same questions. Okay, I'm repeating the questions, but this time the approach is different. Last time, what did I say? Convert total kinetic energy plus total initial kinetic energy plus initial potential energy, final kinetic energy plus final. Equate. అదే కదా? Now, okay, Spandana, now I'm telling you to see, చూసుకోండి which form of energy is converting it into which form. Okay, చూసుకో అందరికి. So this is my spring. అంతే కదా? Yes, spring constant K. This is my block. Mass M, speed U ra, maximum compression కావాలి. It is thrown like this. What form of energy does it have right now? చెప్పు అందరికి. What form is it having right now? What form of energy is it having right now? Kinetic energy. How much? Half mu square. అదే. So sir, మొత్తం energy is half mu square. It is converting into spring potential energy. Formula ఏంటిరా spring potential energy కి formula చెప్పండి. half kx square కదా? Yes. So sir, half mu is equals to half kx square. ఎక్కడి నుంచి x is equals to u root m by k. అదే one liner questions. If you understand this method, right, the questions are only one liner questions. But remember, okay, all these methods, conversion of one form to another form, they are only valid for conservative forces. Non-conservative force వచ్చి you have to change the approach by yourself. Okay, so for now keep yourself relaxed, completely relaxed. We are going to solve few good number of questions. తీసుకోండి. Next, this is my third question. అందరికి చూడండి. Okay, this was the initial condition ra. Initial condition అంటే initially there was a compression of x. చూసుకోండి. Initial compression is equals to x. అర్థమైంది కదా? Yes sir, initial compression is x. Mass is m ra. చూసుకోండి. Spring constant is k. అందరికి what energy does it have now? Compression is there, x. Compression is there, x. Mass is m. What is the energy this block is having, Ray? Initially cheppandi, what is the energy this block is having? All of you, I need the answer. Okay, I need the answer. It's a very simple question, ra. Tell me, cheppandi andariki. What is the energy this block is having? Sir, x is the compression, k is the spring constant. What is the energy? Not zero. It's not zero. Energy is not zero. I'm telling you again, energy is not zero. Right. Very good. Go not very good. So the energy initial is half kx square. Very good. So initial energy ante compression form kada. So initial energy is half kx square. Ippudu we have released the block. Ante slowly the speed of the block is increasing. The spring is pushing this block kada. Conservative force. Spring force is a conservative force. Cheppandi. Final scenario lo the spring elongation is x by 2 now. Okay, this elongation in the spring is x by 2. Naku speed kavalira, v is equals to 80. I want the speed. I will tell you the hint, all of you. Understand the question first. Initially half kx square energy, no problem. Final scenario, look, the compression was x, it has increased until the compression decreased. X by 2 is the compression now. The speed of the block has increased. How much speed? Hint. Total energy that it has gone in two things, right? In two things, it had converted, right? Yes. Sir, total energy was this. Some of it is still in the form of potential energy. Choose for hey, some energy is again yet till even now is in the form of spring potential energy, and some of it got converted into kinetic energy. Ade kada. How will I write the equation? Tell me. How will I write the equation? So, sir, understand, initial kinetic energy is half kx square. So this is idena initial energy ante kada. Mottam energy ante potential energy, sorry, initial potential energy. Mottam energy ante initial potential energy. Final scenario lo cheppandi, what is the potential energy remaining ra? Remaining potential energy cheppandi. Sir, half k into x by 2 whole square ade kada. And the remaining energy lost in the form of kinetic energy ante converted from potential to kinetic ante half mv square. How many of you understood this question? How many of you have understood this equation? Cheppandi andariki. How many of you have understood this equation? Okay. Nice. Good. So, sir, half kx square is equals to 1 by 8 kx square plus half mv square. You send everything this side, ra. So, sir, half kx square minus 1 by 8 kx square v square. Ade kada 1 by 2 minus 1 by 8 entara? Sir, 8 minus 6 by 16, 3 by 8, 3 by 8, 3 by 8. Ade kada 3 by 8 kx square is equals to 1 by 2 mv square. Ekkada nunchi you can simply cancel out 2. So 3 by 4 k into x square is equals to mv square. That means v is equals to root 3. Hey, directly I'm writing. Okay, I'm writing x by 2 into root 3k by m. So this is the speed of the block. I hope you are understanding this. Ardhamaindi andariki. Chusko, all the initial energy now has converted some as the potential energy only, but some as kinetic energy. So initial energy has converted into two forms, ra. Potential, kinetic. Ade kada? Hi. Sagar, hi. Having any doubts, Ray? Good. Next question. Okay, next question. Chuskondi andariki. In the next question, I'm asking you this thing. Okay, remember, the object has been thrown up with the speed u, ra. Andariki. What will be the speed of the object? If unnitty questions, we can also solve it using your kinematics equation. V is equals to u plus at, s is equals to ut plus half at square, and all these things. Okay, but it is a simple way. It's a simple way. Very simple. Very good. So initial speed is u, ray. Let us say it has covered a height of h by 3. h by 3 ante enti ra? Total height h ki 1/3 height it has attained now. So cheppandi, what will be the speed at this point, ra? Naku v kavali. Cheppandi andariki. Initial speed is u, h by 3 height is covered. Final speed kavali. Andariki cheppandi. How will you do it? You want hint? Hint simply says the total initial kinetic energy has converted in two forms. One, potential energy increase. Second, still some kinetic energy left kada. Yes, you do it. Let us see. Okay. Sir, initial energy is half mu square. Ade kada. It has completely converted in two forms. And not converted, this energy has been broken down. Broken down ante koncham energy is still, it is there in the form of kinetic energy. I don't know the value of m, so I'm telling half mv square plus ఎంత డిస్టెన్స్ కవర్ చేసిందిరా h by 3 అంటే ఇంక్రీజ్ ఇన్ పొటెన్షియల్ ఎనర్జీ. చెప్పండి mg h by 3 అదే కదా? ఎస్, mg h by 3. సో m gone రైట్, అదే కదా? ఎస్. యు సెండ్ ఇట్ దిస్ సైడ్ ప్లస్ gh by 3, you send it, it becomes minus gh by 3. So u square by 2 minus gh by 3 is equals to half v square. అదే కదా? 2 division, standard multiplication. So u square minus 2g h by 3 is equals to v square. Adhe, take square root. V is equals to who did not understand this? Who did not understand this? Good. Next rate. Two, 3 minutes more. Okay, more 2-3 minutes. చెప్పండి అందరికి. Initially, you are releasing it. Initial energy ఏంటిరా? gravitational potential. Height is there. Height is there. Gravitational potential is there. How much? mgh. So it has this much amount of energy mgh now. Final case no, it is falling down and came this point. At this instance, height is h by 6. అంతే కదా, నాకు స్పీడ్ కావాలి. v is equals to what? చెప్పు. This energy has converted into kinetic has some potential energy. Okay? Totally potential has converted in some kinetic has some potential. అదే కదా. So sir, mgh is the total energy. It got converted into mg into h by 6. అదే కదా. Plus half mv square. ఇదే. Right? You subtract. m gone. చెప్పు. So sir, gh minus gh by 6 is equals to half v square. అదే కదా. 5gh by 6 is equals to half v square. You send it that side. So sir, 5gh by 3 is equals to v square, and v is equals to root of 5gh by 3. Very good. Go not. Next. Good. Next question. Choose one. If you are getting this answer, that means your grip is getting stronger and stronger. Okay? Am I audible now? Am I audible? I hope am I audible now? Okay. Next question, bro. తీసుకోండి అందరికి. Next question. All of you. An object hey, not release now. Okay. Now I think okay, let us take release. Hey, don't do it using kinematics, huh? You don't do it using kinematics. I'm telling you, hey, there is no use. You must do it using work power. You know that conversion of energy format. చెప్పండి. Ritik, did you calculate it using this conversion of energy formula? If you're using it, if you're using your equations of motion, that's it. Everything is waste. Okay. If you're using equations of motion, waste. చూద్దాం అందరికి. సి హైట్ h కదా, అంటే ఇనీషియల్ పొటెన్షియల్ ఎనర్జీ హౌ మచ్? టెల్ మీ. సార్ ఇనీషియల్ పొటెన్షియల్ ఎనర్జీ ఈజ్ mgh. అదే కదా? ఎస్. హౌ మచ్ డిస్టెన్స్ కవర్డ్ రా? 2/3 కవర్డ్. అంటే హౌ మచ్ లెఫ్ట్? 1/3 లెఫ్ట్. ఇదే కదా? ఎస్. సో 1/3h is left. అంటే ఇప్పుడు ఆల్సో now also it is having some potential energy ఎందుకంటే it's above the ground, right? Yes. How much potential energy రే? Sir, mgh/3 అదే. And what about kinetic energy? Half mv². అంతే కదా? Yes. So total energy got distributed some in this, some in this. Total energy some in this, some in this. అంటే total energy mgh got distributed half mv² plus mgh/3. m gone, right? Gone. Sir, gh minus gh/3 is equals to half v². So ఇక్కడ నుంచి you can simply say 4gh/3 is equals to v². v is equals to root 4gh divided by 3. If you are doing by this method, well and good. If you are doing using your kinematics, gone. ఎందుకంటే I am going to give you a few more questions. తీసుకోండి. Now you must understand which energy is getting converted into which form. సరే, root 4gh/3 చూసుకోండి. maximum compression how much రే? maximum compression కోసం there should be a condition. ఏం conditions are? total energy that is in the kinetic energy form must be converted into potential energy. అంతే కదా? yes. for maximum compression total kinetic energy is converted to total potential energy. చూసుకోండిరా. అంటే x is equals to v root of m/k. అదే. It is maximum compression kada, but it is not telling at maximum compression, right? It's telling half the maximum compression. Ante ippudu the compression in the spring is equals to x0/2 ante v root m/k divided by 2 ra. Ante x is equals to v/2 root of m/k. Right? Yes. So ante ee instance lo chuskondi, when the block is coming here, it has some speed v, it has it. At the same time, it has some elongation, right? x/2. x/2 అంటే this much. చెప్పండి సార్, half k x². x² అంటే this square రా, plus half mv². Why am I writing, sir? Should be equals to half mv². చూసుకోండి, this was the initial energy రా. Total energy, initial energy నుంచి some got converted into the final potential kinetic energy and final potential energy. Understanding? Not understanding. Sure. Good. చెప్పు. So now you can also say, sir, half mu square is equals to half k into x value ra. X value anta v by 2 root m by k square it. So sir, v square by 4 into m by k ade kada plus half m v square. Naku v square kavali ra. M gone, k gone ade kada. Sir, 1 by 2 u square should be equals to cheppandi how much re? Sir, the 1 by 8 u square ide kada. So you can cancel out half also. So u square is equals to u square by 4 plus v square ante v square is equals to 3u square by 4 root తీసుకోండి v is equals to u by 2 into root 3 ade. So this is the speed. If you are understanding, well and good. If you are not understanding, let's move further. No, you also calculate the value of x-ray. Next, చూసుకోండి. ఇప్పుడు let us talk about non-conservative forces. Okay. So ఈ forces కోసం అందరికి చూసుకోండి. For non-conservative forces, you are not understanding, you tell me, right? Don't sit silently, okay? If you don't understand anything, it is your responsibility. Tell me all of them. Okay? Hi, hello, ghost. Hello. చెప్పండి. Non-conservative forces ante entira? These forces will do work. For sure, these forces will do work. Okay? These forces will do work. Kani, these forces will steal energy from the system. For example, I'll tell you. For example, you understand. Okay? This is my block. Mass m unte, speed is u. Let us say coefficient of friction is mu. I'm telling you an example. Okay? Final scenario lo, mass is m, speed is u by 2. Chappo. What is initial kinetic energy? Sir, half m u square. It is my initial kinetic energy. Ante kada. What is final kinetic energy? Sir, half m into u square. Ante u by 2 whole square. Ante 1 by 8 m into u square. So this is my kinetic energy final. Ade kada. Changed. Chusko. Initial energy was this. Final energy was this. Ante some energy has gone. Where did it go? In doing work. Ante kada. Yes. So change in the internal energy. Leda, you can simply say, sir, change in the energy is equals to negative of work done. Right? Negative of work. You can simply say that. Leda, you remember these formulas only, okay? But. Hey, choose ko andariki. But you must have the idea of initial energy and final energies. Initial and final instances ki koncham idea undale. Then and only then you can talk about the energy changes. Chusko. Again, I'm giving you clear-cut formulas. Okay? Formula number 1. For conservative forces, if you did not understand that method, conservative forces kosam gurtu pettukondi. Initial energy, total initial energy EI must be equals to total final energy EF. Ade kada. Initial energy lo rendu rakala energy unnayra. Kinetic energy initial plus potential energy initial must be equals to kinetic energy final plus potential energy final. This is the only condition for your conservative forces. Okay? Not listening to me. Hi Gitanjali. Hi. Okay, so this is the condition for your conservative forces. But when it comes to non-conservative forces, andarki chudandi. For non-conservative forces, what will you say, For non-conservative forces, we are using a theorem known as work energy theorem. All of you. Work energy theorem. Ante entira? Work energy theorem lo, we simply say that the change in all the energy of the system, ardham cheskondi, the total change in the energy is gone in doing work. Understanding? Yes. So sir, total change in energy is gone in total work done. Ade. So ante EF minus EI is equals to work done. This is the work energy theorem. Let us take examples also. Okay, let us take examples one by one. Choose Kundira. So let us talk about friction. Ante half 10 u square is 20 square is directly 400. Ade kada? So that is 2000 joule. 2000 joule of initial energy was there. Final energy how much is remaining? V0 ante half m v square kuda 0. Ade kada? Yes. So what can I say now? Sir, you can simply say change in the energy is equals to work done by friction. Ante kada? Yes. Sir, what is the change in energy, sir? EF minus EI is equals to minus work done by friction. EF entara 0 minus EI entara 2000 is equals to work done, negative of work done by friction, and 2000 is equals to work done by friction. Work done by friction eppudu work done by friction how much re? Work done by friction cheppandi andariki. Work done by friction is force time displacement kada? Yes. Force entara mu n work done by friction ante mu into n into displacement. Idi na force, here is my displacement. Chuskondi F into S. So sir, 2000 is equals to mu into n into S. Displacement, I am going to calculate displacement. Okay, so sir, 2000 is equals to cheppandi andariki mu value entara 0.2, normal reaction enta 100 multiplied by displacement. Ade kada? So you can simply say sir, 2000 is equals to 20 into S. Ekkadi nunchi displacement is equals to 2000 divided by 20 and 100 meter of displacement is there. Finished. 100 meter displacement. Ade kada? Good. Next question తీసుకోండి అందరికి. Same process, okay? Same principle రా, same principle. Mass 10 kg తీసుకోండి. Initial speed u is equals to 10 meter per second తీసుకోండి. Now, coefficient of friction mu is equals to 0.1, right? Okay, not 0.1. Let us take 0.4. And let us say the speed is reduced to 5 meter per second now. Cheppandi andariki 5 meter per second. Ade kada? Find the displacement, right? Find the displacement. Find displacement. Cheppandi andariki. Find the displacement. Same process. What formula to use? Same formula. What same formula, sir? I don't know. Okay. I don't know. $93 meters. చూద్దాం. Formula you understand, okay? Whenever such questions are given to you, the first thing that you will be doing is check if it's a conservative or non-conservative force. Non-conservative force unte, you apply a single formula. What is the formula, sir? You can simply say, sir, change in the energy is equals to work done by the force. Same force, sir? Non-conservative force. Change in energy formula ente final energy minus initial energy. Why is it creating so much problem? Okay. Final energy minus initial energy should be equals to work done. Ante kada? Yes, work done. First focus on left side. దాని తర్వాత ఫోకస్ ఆన్ రైట్ సైడ్. చెప్పండి అందరికి. సో లెఫ్ట్ సైడ్ కి వాల్యూస్ ఏంటిరా? ఫైనల్ ఎనర్జీ ఎంతరా? హాఫ్ mv². అంటే హాఫ్ మాస్ v² అంటే 5² is 25 మైనస్ చెప్పండి ఇనిషియల్ కైనెటిక్ ఎనర్జీ హౌ మచ్ రే? హాఫ్ మాస్ ఇంటూ ఇనిషియల్ స్పీడ్ ఎంతరా? 10² is 100. అదే కదా, షుడ్ బి ఈక్వల్స్ టు వర్క్ డన్. క్యాలిక్యులేట్ చేసుకోండి. ఫస్ట్ ఆఫ్ ఆల్ క్యాలిక్యులేట్ దిస్ ఆల్ ఆఫ్ యూ. సో కెన్ ఐ సింప్లీ సే, sir, this minus this is directly equals to 5 into 75. అదే కదా? Yes. Should be equals to work done by friction. చూసుకోండి 5 into 75 ఎంతరా? 375. Negative 375 is equals to work done by friction. ఎప్పుడు once your left side is solved, then you go for solving right side. Right side అంటే work done by friction. Formula ఏంటిరా? Force into displacement. Negative work కదా? Force left, displacement right. 180 degree angle ante work done will be negative. So minus force entara? Mu into n. Mu into n. Mu value is 0.4. Normal reaction is 100 multiplied by displacement. Ade kada? Negative negative gone. So sir, 375 is equals to 40 multiplied by displacement. So displacement is equals to 375 divided by 40. Ade kada? Yes. So you can simply say 75 by 8 meters. అందరికి చూడండి. ఓకే, నెక్స్ట్. హే, ఐఎమ్ గోనా టేక్ 5-6 క్వశ్చన్స్ బేస్డ్ ఆన్ దిస్ ఓన్లీ. దాని తర్వాత విల్ మూవ్ టువర్డ్స్ సంథింగ్ ఎల్స్. లేదా ఇఫ్ యూ వాంట్ మీ వీ కెన్ డైరెక్ట్లీ గో ఫర్ PYQs. ఓకే, PYQs చూద్దాం. హౌ మెనీ PYQs హ్యావ్ బీన్ ఆస్క్డ్? ఓకే, let it be. Okay, చెప్పండి. ఐ వాంట్ యూ టు ఆన్సర్ దిస్. అట్లీస్ట్ ఆన్సర్ దిస్ క్వశ్చన్ రా. పొటెన్షియల్ ఎనర్జీకి ఫార్ములా ఏంటి అందరికి చెప్పండి. ఇట్స్ వెరీ ఈజీ క్వశ్చన్స్. Okay. Not some mistakes. No mistakes. Okay. So u is equals to half k x squared. Ante kada? Yes. When the elongation was 2 centimeter, 2 centimeter, it is u. So ante half k into 2 squared. Ante enti sir? U is equals to 2k. Ade kada? Good. Good. Now, you do one thing. Elongate by 8 centimeter. So sir, u dash is equals to half into k into cheppandi 8 squared kada? Yes. So sir, half into 64 into k. And that is equals to 32k. Ide kada u dash value ra. Kani 2k is u. So sir, u dash is equals to 16 into 2k sir. Ante u dash is equals to 16 into u. Ide. Finished. Hey, before that, okay, let us quickly go towards understanding. Okay? One information that I want to give all of you. Whoever has not registered for the test, andariki, you please go and register cheskondi. Okay. Again, for the students who don't know about the test, this test is conducting on 3 days. Okay. First one is your 4th January. Dan tarvata 11th of Jan and then 18th of Jan. Timings same untundi 2 p.m. to 5 p.m. for NEET students. Test is given in such a way that for your first test, you will be getting the material. Registration absolutely free of cost. ఈ వీడియోకి డిస్క్రిప్షన్లో లేదా ప్రీవియస్ వీడియోకి డిస్క్రిప్షన్లో వెళ్ళి go click the link, register yourself. Okay, I want all the students to appear for this test. I want all the students to appear for this test. అదే కదా? Okay. Yes, so last date to register is 3rd of January and 4th Jan nunchi tests are getting started. Okay, good. So with that being said, let us move towards our next topic ra. Okay, తొందరగా చూసుకోండి అందరికి. So each and every question has some significance. So ఇప్పుడు let us talk about relationship between potential energy అందరికి చూడండి. ఓకే, సో ఇఫ్ యూ హ్యావ్ కాన్సర్వేటివ్ ఫోర్స్ ఓకే, కాన్సర్వేటివ్ ఫోర్స్ ఉంటే ఏ పొటెన్షియల్ ఎనర్జీ is only defined for conservative force. Okay, potential energy is only defined for the conservative force. అందరికి చూడండి. So if we have potential energy U is equals to 3x squared plus 4x plus 6, and it is varying with the position. It is varying with the position. Ante kada? You get the force as F is equals to cheppandi andariki minus du by dx. All of you tell me. Ante you can simply say sir d by dx of 3x squared plus 4x plus 6. Ide kada? So your force F is equals to cheppandi 6x plus 4. Ide. Sir, this is force, this is potential energy. So now I'm talking about equilibrium. చూసుకోండి అందరికి. I'm talking about equilibrium. So equilibrium అంటే ఏంటిరా? Equilibrium is a condition where the force is zero. అంతే కదా? force becomes 0. Ade. Okay, so that means for equilibrium, cheppandi andiri. For equilibrium, F is equals to 0 and du by dx should also be equals to 0. Ade. Very important identity. Okay, very important results ra andariki chudandi. So oka question తీసుకోండి. As u is equals to u of x, later it should be given in this form. U is equals to 6x square minus 12x plus 18. Right. Okay. చెప్పండి అందరికి. Right. 12x minus 12. It's the force. Equilibrium ante enti? Equilibrium ante the force should be 0. Ade kada? Yes. At what position is the force getting 0? At x is equals to? At x is equals to? Good. X is equals to 1 meter is the position of the equilibrium. చూసుకోండి. Now, stable equilibrium రా. What is stable equilibrium? దాని తర్వాత unstable equilibrium అదే కదా. Yes, stable equilibrium. Then you have unstable equilibrium. After that you have neutral equilibrium. What are this? What are this? చూద్దాం అందరికి. So when the stable equilibrium is concerned, అందరికి చూడండి, I'll just give you the formulas. Okay, we don't have to jump to the results or the proof Okay, I'm just giving you the formulas. Remember the formulas only. Formula is number one, sir. For stable equilibrium, force and torque must be zero. Ante same ra, force should be equals to zero. Ante F is equals to zero. That means du by dx should be equals to zero. Number one condition. Condition number two ra, second derivative. Del square u ra. Del square u divided by del x d square u by dx square should be positive. Positive ante enti ra? Minimum value. Minimum value of potential energy. Stable equilibrium has minimum potential energy. You remember this, okay? You remember this potential energy. Ante enti, I'll explain you. I'll explain you now. You observe it very carefully. Andariki chudandi. So na దగ్గర ఒక sphere రా, hemisphere. Can you visualize hemisphere? Yes. So ide na hemisphere. What I'm doing now is I'm placing the ball right at the bottom of this hemisphere. ఇప్పుడు place చేసిన తర్వాత what I'm doing is I'm slightly pushing it. Okay, I'm slightly pushing it. What will happen? ఏమైతది? So when I push it, the ball goes here. After that, it comes to the original position. Similarly, you send that ball here, it will again come back to the original position. Ante kada? So this is the stable equilibrium. All of you observe it. Observe it. Okay? This is the stable equilibrium. Equations గుర్తుపెట్టుకోండి. Number one, du by dx 0. Ante first derivative 0. Second derivative positive. Okay, so whenever you see such condition, right, you understand it is a type of stable equilibrium. Ante kada? Right. Next, unstable equilibrium. Andariki unstable equilibrium. The second type is unstable చెప్పండి. Unstable equilibrium ante even at this point the force is zero. Okay, unstable equilibrium lo kuda the force is zero, kani the potential energy is not minimum. Understanding, there will be some value of the potential energy, but force is zero for sure. So that means F is equals to zero ante du by dx is equals to zero. Equation number one. Ade kada? Dan tarvata you cannot say, sir, the potential energy is not minimum ante it should be maximum ra. Potential energy is maximum in that given range. Mathematical terms. Okay? Leave it. So these are the two equations, right? Unstable equilibrium ante enti ra? You imagine you have a hemisphere. Again the hemisphere, but it is placed upside down. Something like this. Chusko. So when you are placing a ball, right? When you are placing a ball somewhere here, you just slowly, carefully place it. Dan tarvata you observe that it is not moving ante the force is zero. Ade kada? But when you slightly disturb it, you move it something like this, it will fall down, right? Leda, you move it something like this, it will fall down. And it's not going to stay on that position. Ante kada? Good. Saying something, right? Yes. Good. Next, let us talk about neutral equilibrium. Andariki. It's not required actually, but I'm telling you. Okay. Neutral equilibrium ante entira? Neutral equilibrium lo your force must be zero. Equilibrium ante force is zero for sure. Sir, F is equals to zero ante du by dx is equals to zero. Equation number one. What about second derivative, sir? Dani idi kuda zero ra. Ade. So this is your neutral equilibrium. Example entira? Example is a cylinder rolling on the ground. A cylinder rolling on the ground. You slightly push it. It will be in the equilibrium. You push it, pull it, equilibrium. Ade kada? Yes. So this is my neutral equilibrium. Andariki chuskondi. Now let us take some questions, right? చెప్పండి అందరికి. So this is the question. Okay, you do it. I'll be back in 2 minutes. Okay, water. Hey, that's not done, Ray. I'll tell you one thing. Okay, I'll tell you one thing. Everything could stop, but your chats will not stop. Right? And when you see your chats, 85% of the chats are useless. Hey, what are you doing, Ray? Where are you from, Ray? Are you boy or girl, Ray? Huh? What do you have to do, Ray? Huh? Good. Chudam, andariki. So first of all, f is equals to, sir, f is equals to du by dx. Ide kada ante d by dx of u. So sir, 3 upon x squared plus 2x squared. Ade kada? Right. So that means d by dx of, now you have to convert, ela convert cheyali sir. It is 3x to the power minus 2 ra, 1 by x square, x to the power minus 2 plus 2x square kada. Yes, 2x square. Differentiate cheskondi. So first term becomes, sir, d by dx of 3 into x to the power minus 2 plus d by dx of 2 into x to the power 2. Ade kada? Right. Good. Good. Cheppandi andariki. So now what you can say is, sir, it is equals to, f is equals to minus 6x to the power minus 3 plus 4x. Ide kada? Yes. So that should be equals to 0. Hey, did I do some mistake, Ray? I think I should have given 2x only, Ra. Okay? Because it's a little mistake from my side. But let it be. We can do it. Okay, we can do it. It should be equals to 0. And minus 6 by x cube plus 4 into x should be equals to 0. And 4x should be equals to minus 6 by x cube. Ra. Send it there, sir. X to the power 4 should be equals to, not minus, plus. So x to the power 4 should be equals to 6 by 4 and 3 by 2. That means x is equals to 3 by 2 to the power 1 by 4. So this is the point of equilibrium. Ante kada? This is the point of equilibrium. Very good. Very good. Very good. Very good. Now, let us talk about the nature of the equilibrium. Ela find cheyali sir? Again differentiate. Malli okasari differentiate cheyandi. Tell me. So sir, this is the derivative. That is the derivative, right? This is the derivative. Differentiate again it. Hey. So d by dx of minus 6x to the power 3 plus 4x. Ide kada? Same answer, right? Plus 4x, right? Chappu. So you simplify. You will get, sir, minus minus becomes plus. So 18x to the power minus 4 plus 4. Ide kada? This is your derivative. So to check or to say, so it is simply equals to 18 divided by x to the power 4 plus 4. Now I don't want you to include in some mathematics term ra. Chuskondi. D square u actually. So it should be d square u by dt squared. So it is d squared u upon dx squared is this. Yedaina value teeskondi. Whatever value of x you take, this expression is always positive. Endukante the power is an even number. Ante kada? Power is even number ra. So it is always positive. And it is an example of d square u divided by dx square. It is always positive. Positive unte stable equilibrium. Ante kada? Yes. So this is the case of stable equilibrium. Right? Okay. So chuddam. One more question I have for you. Cheppandi andariki. True or false? True or false? Okay, true or false? Spring force has unstable equilibrium. Cheppandi. Spring force has unstable equilibrium. And the spring has unstable equilibrium. ఏదైనా తీసుకోవచ్చు. చెప్పండి అందరికి. What are you doing, Ray? True or false? True or false? Cheppandi andariki. Is it true or is it false? Stable equilibrium ante enti sir? Ela find cheyali. So how to know it? Gunat, we will use the same formula. Equilibrium ante du by dx and d squared u by dx squared. What is u? Potential energy stored in the spring. What is the formula? Half kx square. Now do it. Okay? Now do it. Now do it. The logic is not like this. Logic works based on the formulas. So this is the first formula, this is the second formula. Okay? Not true. Not true. It's a false. It's a false statement. Andariki, it's a false. It has always a stable equilibrium. I will tell you. Okay? Okasari, you take the potential energy as half kx square. Differentiate cheskondi, double differentiate cheskondi. You understand automatically what's the answer. Hey, all of you like the video, sir. First of all, you leave all your works. ఒకసారి లైక్ చేసుకోండి ఈ వీడియోని. ఓకే ఓకే గుడ్. చెప్పురా సార్, పొటెన్షియల్ ఎనర్జీ స్టోర్డ్ ఇన్ ద స్ప్రింగ్ ఇస్ గివెన్ యాజ్ హాఫ్ kx స్క్వేర్. ఇదే కదా? ఎస్, గుడ్. వాట్ అబౌట్ ఫోర్స్? వాట్ అబౌట్ ఫోర్స్? వాట్ అబౌట్ ఫోర్స్ రా? సార్, F is equals to du by dx. ఇదే కదా? ఎస్. అంటే d by dx of half kx squared. Simplify. It comes out to be kx. Right? Yes. What about the double derivative, ra? Double derivative ante d by dx of kx is equals to what, ra? K. K value is positive. That means it has a stable equilibrium. I will explain you in one more way, ra. Chusko. So what happens is, if this is a block of mass m, spring constant k, if you disturb it slightly, what will happen? It will try to pull towards himself, and then it will pull towards the left, then back and forth, back and forth, back and forth. Slowly it will set at the same point. Ante kada? Yes. It will slowly set at the same point. Same point. Chuskondi. Okay, very good. Very good. Yes, good, great. Next. Okay, let us leave the questions. Now let us talk about a concept. Then we'll discuss some PYQs. Okay? Then everything is completed. Power. Power ante enti sir? Rate of energy change లేదా rate of work. చూసుకోండి. Power is delivered by friction. చూసుకోండి. It is the question అందరికి. So this is a block. Mass m is equals to not mass m, right? 10 kgs. తీసుకోండి. Mass is 10 kgs. Coefficient of friction mu is 0.2. Initial speed was u is equals to 10 meter per second. Okay. Final scenario లో 10 kg v0. Okay. నాకు పవర్ కావాలి. You do everything by yourself. ఒక్కసారి వర్క్ క్యాలిక్యులేట్ చేసుకోండి. దాని తర్వాత you calculate time and then you calculate the power. Okay. Is it still buffering? చెప్పండి అందరికి. What is the power? So to calculate power, you need to calculate work. Calculate work. You need to talk about work energy theorem. Sir, change in the total energy is equals to work done by friction. What is change in energy, ra? I don't know. Just take it up. Okay. Okay, చూద్దాం. So sir, పవర్ కావాలి కదా. సో పవర్ కోసం ఫస్ట్ యూ హ్యావ్ టు టాక్ అబౌట్ వర్క్ రా. వర్క్ ఎలా క్యాలిక్యులేట్ చేయాలి సార్? సార్ యూ కెన్ సింప్లీ సే వర్క్ డన్ ఇస్ నథింగ్ బట్ చేంజ్ ఇన్ ద ఎనర్జీ. అదే కదా, చేంజ్ ఇన్ ద కైనెటిక్ ఎనర్జీ. అంటే హాఫ్ m u square అంటే హాఫ్ మాస్ u square అంటే 100, దట్ ఈస్ ఈక్వల్స్ టు 500 జూల్ ఇస్ ద వర్క్. డైరెక్ట్ ఆన్సర్, డైరెక్ట్. యూ డోంట్ హ్యావ్ టు క్యాలిక్యులేట్ సార్. v square is equals to u square plus 2s. దీనిలోంచి you go for displacement, then you calculate. Hey, too much long. It is the work done. Finished. Ante kada? Yes. Divided by time. Time how much? Sir, v is equals to u minus 80. Acceleration entara. Acceleration is minus mu into g. You remember this formula also. Okay, I know it. That's what I'm telling you. Sir, v is equals to u minus mu into g into t. Ade kada? Sir, time is equals to u divided by mu into g. What is the value of u ray? 10. What is the value of mu ray? 2 into g. Ade kada? So time is 5 seconds. Very good. Very good. Go not very good. So time is 5 seconds. Work is minus 500 actually. Actually work is minus 500. Okay. దాని తర్వాత I can simply say that power is equals to w by t అంటే minus 500 divided by 5 అంటే minus 100 watt. Okay. Watt is the unit of power. Next. తీసుకోండి. You try this also. Okay. Yes. Work is not a vector quantity, okay? Power is not a vector quantity. Power is a scalar quantity. Always remember this. Your power is always a scalar quantity. Let us see. It has been asked in JEE mains, okay? JEE mains question. This is JEE mains question, okay? It has been asked in JEE mains. This one. I have F. Now they S kuda untundi, but I don't have time, right? I don't have time. So first, naku time kavali ra. How do you find time? How to find time? Cheppandi andariki. I think this question is not right, right? I think I will have to adjust the values very carefully. We get the acceleration. Acceleration is equals to 2i plus 5j plus 6k. Ide kada? Yes. So it should be 6 ray. Hey, you do one thing. You change these values, okay? Because sorry, you change these values. You change these values, all of you. 4 Okay, let us take these values and proceed. Andariki. Yes. Yeah, I understood. So these are the values. Choose. So this is acceleration kada. So you take 3 components of acceleration. You can take any one of them. Rest values must match. I did not focus on this part, but it should match. Okay? So displacement cheppandi. 0 to 4 ante 4 meter of displacement in x-axis. Ante kada. S is equals to ut starts from rest. Ade kada. Starts from rest. Half into A in the horizontal, how much? 2 into t squared. Ide kada. 2t gone. T squared is equals to 4 and t is equals to 2 seconds. Finished. T is equals to 2 seconds. Right. Now you have force, you have displacement. Displacement chapora. F bar is equals to 10i plus 25j plus 30k. Similarly, S bar cheppandi. S bar is equals to 4i. Ante kada 4i plus 10j plus 12k. Work. W is equals to F bar dot S bar kada. Cheppandi. 40 plus 250 plus 360. Ante 0, 5 and it is 650. 650 is the joule run and time is equals to 2 seconds. So the answer is 325 watt. Now let us talk about the average power. Okay? Average, instantaneous power. Andariki chudandi. Formula good petkondi. Okay, instantaneous power P instantaneous is equals to F bar dot V bar. V ante velocity. F bar dot V bar. V is the velocity. Okay, Now let us see a PYQ. Directly PYQ తీస్తున్నారు చూసుకోండి అందరికి. Question. చెప్పండి. సేమ్ ఫార్ములా ఎఫ్ బార్ డాట్ వి బార్. వి బార్ క్యాలిక్యులేట్ చేయండి. Okay, let us see. Okay, sir. It's a very easy question, man. Elementary question. S is equals to 2t minus 1. And displacement is ds by dt. That means d by dt of 2t minus 1 kada is equals to 2. This is the speed. Force 5 Newton. Power is equals to F into V. So 5 into 2. 10 watt. Okay, next question తీసుకోండి అందరికి. All PYQs, huh? Now onwards, all are PYQs. Good to go with the PYQs. Okay? We are done with everything. Actually, the question has some misunderstanding. Okay, there is a word. Okay, a particle moves with velocity horizontally. It cannot move horizontally when it has all these values. Okay, it cannot move horizontally under the influence of a force. చెప్పండి. Yes, go ahead. Done. Chapter is done. Your chat sections, yes, absolutely. Swati, very good. Don't stop. Don't do unnecessary things. Okay? Only PYQs, right? Now I think we do have half an hour left. In half an hour, మొత్తం PYQs చూద్దాం అందరికి. Okay, let us talk about. Although the vertical circular motion is not there for your syllabus, vertical circular motion, it does not ask. It is not asked. But in 2025 paper, they have asked that also. So they are asking everything, almost everything they are asking in 2025. As if it's a JEE paper. Chala complicated. I don't think your time will have this much of tough questions. But let us see what happens. Nothing can be said. Okay. చూడండి, ఫార్ములా బేస్డ్ క్వశ్చన్స్ రా. ఇన్స్టంటేనియస్ పవర్ కదా, పవర్ ఇన్స్టంటేనియస్ ఇస్ ఈక్వల్స్ టు ఎఫ్ బార్ డాట్ వి బార్. ఎఫ్ బార్ వాల్యూ ఏంటిరా? 10i ప్లస్ 10j ప్లస్ 20k డాట్ వి బార్ 5i మైనస్ 3j ప్లస్ 6k. ఇదే కదా. So 10 into 5 becomes 50. No ijk ra. Ijk will not be here. Ante kada? Yes. Minus 10 into 3 becomes 30 plus 120 ante 141. Ada. Formula based questions ra. 2025 లో వచ్చిన ఒక క్వశ్చన్ చూద్దాం అందరికి. Cars, not gas. Cars. A and B, two similar cars A and B are 100 and 225 joules. Ade kada, are 100 joule and 225 joules respectively. On applying brakes, okay? On applying brakes. Car A stops after 1000 meters. And car B stops after 1500 meters. Yes, Swati, what should I say? Those students are chatting, they're not seeing the subjects, they're not seeing anything, okay? What they're seeing is they just want to do the time pass. I have myself seen it, okay? I have myself seen it. Yes, go ahead. I'm teaching continuously for 12 hours now. So I came, no, I actually started the class at 9. And I came from my house 8 a.m. So the time is 9 p.m. almost. So 13 hours completely outside. Let us see. చూద్దాం అందరికి similar kinetic energies అంతే కదా, not similar kinetic energies are 100 joules and 225 joules అంతే కదా, రైట్. అంటే all of these kinetic energies have been converted into work done, right? You're applying the brakes until work done, all the energy is gone into work done ante kada. Yes, so sir, kinetic energy 1 is equals to converted into work done 1, k2 is equals to w2 ante kada. I'm doing it first cheppandi. So ante fa s1a, here it is fb sb ade kada. Yes, so sir, kinetic 1 by kinetic 2 is equals to FASA divided by FBSB. అదే కదా? Yes. Good. Good. Values చెప్పండి. 100 and 225. So sir, 100 by 225 is equals to forces I don't know. So I'll simply say sir FA divided by FB multiplied by SA I know. నాకు తెలుసు FSA distances are 1000 and 1500. అదే కదా? So sir 1000 divided by 1500. Gone. And a 2 by 3 only. So it is 4 by 5. So sir, 4 by 5 is equals to FA by FB into 2 by 3. Adhe kada? So send it there. Send it there. Hey. Four by 9, sorry. Ratio, calculation mistakes. 9, okay, 4 by 9, 4 by 9. So 4 by 9 is equals to FA by FB into 2 by 3. So sir, 4 by 9 into 3 by 2 is equals to FA by FB. 3 ones are 3. Good. Good, very good. Okay, very good. Next question, Ra. Let us talk about next PYQ. Okay. 2024 re-NEET exam. Okay, re-NEET and Telugu. There was a huge controversy regarding your NEET 2024. So the exam had to be conducted again. Malli. Choose a question. An object falls. నాట్ ఎనర్జీ, ఇట్ షుడ్ బి కైనెటిక్ ఎనర్జీ, అంతే కదా. చెప్పండి అందరికి. ఎస్ స్వాతి, ఎస్. గుడ్, వెరీ గుడ్. Very good, all of you. Good. It actually takes time, Gunnar. To be honest, the students who get the slang of a teacher, they get so much, understanding of the teacher that the tone and the frequency matches. Oka point tarvata, then everything becomes very easy. And whatever the teacher is explaining, the student grasps it very carefully. So what happened is, there were hundreds of students under me. And this is the experiment I'm telling you. I have seen a lot of the times. And the students don't get habituated. They see or they find me very difficult or different to understand. Not difficult, I would not say different, difficult. Different and a weird type of teacher. But okasari they are set with the tone, that's it. I don't have to repeat also. They'll understand even in my one explanation. Okay? So that's a big thing actually. So you force yourself, right? If you're not understanding for a given teacher, force yourself that you're sitting in his lecture. That's it. You don't do anything, just sit in the lecture. Ade. చూసుకోండి. సో 10 meter కదా. ఎస్. సో ద హైట్ ఆఫ్ ద బిల్డింగ్ ఇస్ 10 meter అందరికి. 10 meter is the height of the building. Release చేసిన తర్వాత can I say, sir, total potential energy is converted into total kinetic energy. అంటే mgh total potential energy converted into total kinetic energy, mm gone, v is equals to root 2gh. You can simply remember this, Ray. I would not do all these calculations, useless time waste in NEET examination. You must remember the final speed. Ante kada? Yes. So you can simply say, sir, v is equals to root 2gh is the formula. Ippudu it is the speed kada, root 2gh is the speed, ante half mv square is the energy ra, kinetic energy. Half mv square ante mgh is the kinetic energy. Ippudu as soon as the collision is happened, dan tarvata 50% of the kinetic energy is gone. Ade kada. Ippudu it has the total kinetic energy of half of initial kinetic energy, half mv square. Are you understanding? Ante half of mgh. So it has to completely go there, right? So you can simply say half of mgh is equals to m into g into h dash ra. So mg gone, h dash is equals to h by 2. Ante 10 by 2. Ante 5 meters. Finished. Okay. Next question. Andariki. It's a very good question. Now, I think some lift question is there. I did not see it properly. Yeah, good. చెప్పండి. Hello, Amulya. Hello. You understand, minimum power ante entira, the net force should be at least equal to the force of gravity plus the friction force. Ade. So if the total forces are equal, then calculate the displacement. Ade. Chodam, let us see. Go not, let us see. Okay. I also don't know the answer, but let us see. Okay, listen all of you. So sir, idena lift. Ante kada? Yes. Mass of the lift plus passenger is 2000 kgs. And it is moving in a rail. For example, let us see. Friction force F is equals to how much? 3000. Ide kada? Yes. 3000 is the friction force opposing the motion. Moving up, right? So it is moving up. Choose kondira. Gravitational is acting downward. Friction is acting upwards. Ante kada? No. Gravity is acting downward. Friction is also acting downward. Indukante lift is moving upwards, right? Yes. So gravity 2000 is acting in the downward. Plus friction is also in the downward direction. So ante net force is equals to 5000 Newton. Choose kondi andariki. Net force is equals to 5000 Newton. Ade kada? Yes. What do I want? Power. What is power, sir? W by time. W ante enti ra? F into S. Divided by time kada? Ante F into S by T. Constant speed kada? Constant speed into distance is equals to speed into time vastundi. So sir, distance by time is equals to speed kada? Yes. So you can simply say, sir, power is equals to force into speed ra. Force enta? Force is 5000 Newton. 5000 Newton of force must be provided. So 5000 multiplied by speed ra. Speed enta? 1.5 meter per second. Ade kada? Cheppandi. 7000. 50,000. I think I'm doing some mistake. It should not be 2000. mg kada? mg is the force andariki. Cheppandi. So it's not 5000 ra. Net force should be equals to mg plus 3000. 3000, 30,000. 3000. In the question also 3000, right? Yes. So sir, net force is equals to mg and 20,000 plus 3000. So that is approximately equals to, not approximately, totally 23,000 Newton is the force. Ante kada? This is the force. So epudu force into speed ra. Ade. So force is, sir, 23,000 multiplied by 1.5. Ide kada? So you can simply say 2300 into 15. So 0, 0, 5, 64,500. Hey, are you going mad, right? Huh? The question is correct. Huh? Let me see the question once. Let me see the question once. 1.5 meter per second, friction force opposing, 3000 Newton is there. Minimum power to deliver F into V ray. F into V and 23,000 into 1.5 and 2,300 into 15 kada? Multiplication. You know, it's been 12 hours. In 12 hours, gone. Okay, gone. So 0, 0, 5, 4 is there. 34,500. It is there, right? Yes, it is there. Option C. Next question. Teeskondi andariki. Actually, they are very easy questions, but you know, I'm feeling lazy. It's a good question. Released from a height h. S3, sorry, not h. It is S. From the surface of Earth. At a certain height, its kinetic energy is 3 times potential energy. The height from the surface of Earth and speed of particle and speed of particle I did not solve this question, okay? But my gut feeling, is telling me I did not solve it. Hey, I promise I did not solve this question, okay? I did not read even it. I did not solve, but my gut feeling is telling me, this is the answer, okay? I don't know if it's right or wrong. Naku teliyadu ra, I'm just telling you, okay? My gut feeling is telling me this is the answer. I will tell you why, okay? I don't know if it is B, good, well and good. If it's not B, you tell me the correct answer. But I am feeling B is correct answer. C is coming. C or B. Spandana, it will be done in 15 minutes from now, okay? How long are we taking? 15 minutes only. 15 minutes, okay? Yes. 9:15. Okay, 9:20 actually. 9:20. Let us end at 9:20. S/4 is correct. What about speed? చూడండి. So you can simply say, why did I say B? Why did I say B? I'll tell you. Okay, I'll tell you the gut feel. I will tell you the gut feel. Okay, you see, option D is 100% wrong. Why? 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 Because it must be amongst these three. The NEET and JEE people, they do not keep very easy options, or not odd man out. You'll have to find one amongst the answer kada. So you'll have to find one. You will have to find one. So ante any one amongst the three will be correct. Ante kada. Speed gurinchi re chuskondi. Speed kavali kada. Speed. E formula, this is dimensionally not correct for speed. Meter per second, right? Meter per second square. Chuskondi. G is acceleration, sir. Its dimension is meter per second square multiplied by meter. Chusko. So meter square per second square gone. Dimensionally not correct. This gone. This is gone. Ante kada. Now remaining are these two. Out of these two, chusko. Out of these two, hey, no. See, I think C is also correct. Out of these two, you see the option D. Here. It has given same option D. Are you understanding? That means it might be one of the two options, ra. No, it does not give any odd man out directly. So if this is standing odd man out in D option, these are the two. I know this is wrong, so I think this is right. I don't know. Okay, I don't know. Are you understanding? I don't know. If C is coming, well and good. Okay, if C is coming, well and good. If C is not coming, let us see. Chuddam. What does the question say? A particle released from height s from the surface at a certain height, kinetic energy is 3 times potential energy. Ante chuskondi. So this is the total height s kada. So let us say at this instance, the kinetic energy half mv square. Let us say this, not this. Let us say from ground the height is x. Let us say from ground the height is x. Andarki chudandi. Ante half mv square is the kinetic energy. Potential energy cheppora andariki. Potential energy is mgx. Ade kada. What is it saying? Kinetic energy 3 times potential energy. Ade kada. That's it. So kinetic energy is half mv square is 3 times of m times of g times of x. Understanding? Okay. So under m gone, right? Yes. You talk about the remaining distance, right? Is s minus x. This is s minus x. Sir, the potential energy decrease has converted into the increase in the kinetic energy. And you can simply say half mv square is the increase in kinetic energy. That should be equal to potential energy decrease. That must be equals to mg into s minus x. Ade kada? Yes. So you equate, substitute ra. So half into mg into cheppandi andariki s minus x should be equals to 3 times of mg times of x. Ade kada? M gone ra. G gone ra. Cheppandi. So you can simply say, sir, s minus x is equals to 6 into x. Ade kada? Am I doing some mistake, right? S minus x mg half mv square. No. It should not be 2, right? It should be mg s minus x only. This is the kinetic energy. That is 3 times it. So it should be equals to s minus x is equals to 3x. Ante s is equals to 4x. Ante x is equals to s by 4. Vachindi kada? You pick this value of x. You substitute into this equation. You substitute this into this equation. Cheppandi andariki. So sir, half mv square is equals to 3 mg into s by 4. Ade kada? Yes. M gone. So you can simply send it that side. Chappu. So v square is equals to, what should I write? 3gs by 2. V is equals to root of 3gs divided by. చెప్పండి అందరికి. Yes, Swati C is correct. Yes. How long? Okay, let us see. What is asking? Work done by this force to move particle from 0 to 1 meters. Ide kada? This is the force. F is equals to 20 plus 10y. It's a constant force or it's a variable force? Variable force. Y is there, right? Y is there. Increase y, force increases until it's a variable force. Variable force unte, what would you do? You will simply say W is equals to integral F into dy. Ade kada? All are in y axis, so dy. If they are in x axis, dx, z axis, dz. Ade. Limits cheppo. 0 to 1 meter. So 0 to 1. Finished. So W is equals to integral of 20 plus 10 into y into dy. Ade kada? 0 to 1 ra. Cheppandi andariki. I think I'm taking up too much space, isn't it? Let's do one thing. Let us shift everything that side. This side. Okay. Right. So that means 20 dy, integral 20 dy is 20y plus 10y ante 5y square. Directly I'm writing it, okay? 0 to 1, finished. So it is coming out to be 20 plus 5 ante 25. 25 option not there, not there. 10y square by 2, 20y. 20y 0 to 1 meters, ide kada? So 20 into 1, 20 plus 5y square. Let me just check the options, okay? If everything is written correctly. I can do some mistakes also. 25 joules is there. Hey, option D should be 25 joules, okay? I have written the wrong answer. Option D is there, 25 joules, okay? 25 joules. This is the right answer only. Yes, very good, Gonad, very good. I appreciate it, okay? I appreciate it. No, the options were wrong, but your answer was correct. So, work is equals to 25 joules. Okay? Correct. 25 joules is the correct answer. So, do you want to see one more question and then we'll end up? One last question, bro. One last. Okay, one last question from my end and it is gone. NEET 2016 questions there. Okay, a particle moves from point. Particle moves from a point minus 2i plus 5j to 4j plus 3k. Okay, when a force of I think this is a wrong question, right? I don't know, but I think it's a wrong question. I'll tell you, okay? By done. I'm confused only in this. 5, 8 to 11. 5, 8 to 11. 5, 8 to 11. I think this is a wrong question. Why? Enduku sir? Why a wrong question? It is because you understand. Initially the particle was only moving in x and y direction. Ide kada? Yes. Force is also acting in I and j, and the force is acting in this direction and this direction. Are you understanding? So every system, each and every force and the motion are in the xy plane until no force is there in k cap. So if no force is there in k cap, no acceleration in k cap, no acceleration in k cap, no speed in k cap, no speed in k cap, no displacement in k cap, but there is this displacement it is showing you. Okay? Let us see. Anyhow, that's not gonna get considered. At the end of the day, you will just be calculating in I cap only, I and j. Do it. Change andariki. You're getting the answer, not getting the answer. Cheppu andariki. So now, let us see. I don't know if it's right or wrong. If it's not getting the answer, the question is wrong. Okay? Cheppandi. Sir, work is equals to bar dot s bar. F bar value I have. Naku s bar kavali ra. S bar is equals to R2 bar minus R1 bar. Ide kada? R2 bar ante 4j plus 3k minus of Cheppandi 2i plus 5j. Ante. So you can simply say it is equals to 2i. 4j minus 5j is minus 1j and it is plus 3k. ఇదే కదా. So this is my displacement S bar. F bar చెప్పురా. F bar వాల్యూ అంటే 4i plus 3j ఇదే కదా. So 4i plus 3j చెప్పండి. Multiply dot product అంటే 8 minus 3 that is equals to 5 joule. Answer is there, but question is not valid. Okay, the question needs a little correction. Okay, good. So if you don't have any doubt, can we skip? Yes, I think we can end this session. Andariki. Okay. Okay, bye all of you. I think it's done, right? It's completed. Yes, the session is completed. Sign off from now. Okay, signing off. Thank you, Andariki. Thank you so much. So 2 chapters are completed. Right? We completed current electricity. We completed work power energy. Okay. 2 chapters are completed. I hope these lectures were meaningful. Good. Chalo. Bye. Bye. Bye, Janvi. Bye. Bye, Spandana. Bye, all of you. Thank you, Mysterious. Thank you so much. So I think we should end this session, right? Yes, we're going to end it. So let me just give me a minute. I'll just export it. VF. Then onwards, let's see, work, power, energy, full. Either. Bye, all of you. Bye. Good night. Have sweet dreams and very good night. Chalo. Good night, Andariki. But the biggest thing is that some of you were really attentive and listened to this lecture in a great details. I must appreciate you guys. Okay, chalo, bye all of you. Is it there? Is it there?